We're going to look at section 2b, where we are graphing linear inequalities. All we're doing is graphing lines, except we have to make a couple extra decisions. One is, are we going to shade with a solid line or are we going to have a dashed line? Another is are we going to shade above the line or shade below the line? So those are the questions that we're essentially going to be trying to figure out here. In this first equation, we're in a y equals mx plus b form. So you'll see y mx plus b. And I guess I shouldn't say equals, because here we have a y is less than all of that sign. However, for now, let's just treat it as if it was equals. Let's pretend it's equals for the purposes of doing our initial graph. To do that, we create our axes here, and we go up 4 for our very first point, and I know to do that because that's my y-intercept here. The slope is how much I go over and up. So I go rise of 3, run, or rise of 2, run of 3. So I'm going to go up 2 and over 3 for my second point. And in the same token, I can go down 2 and over 3. So if I continued my line this way, it would look something like this. Now, when I draw that line, that would be as if it was y equals. I now have to go back to my equation and say, what does that symbol tell me? First of all, it tells me that y is less than this line. So y is smaller than that line. So I need to shade below the curve. So that's the first thing. The second thing is less than or greater than is going to give you a dashed line, whereas less than or equal to, greater than or equal to is going to give you a solid line. And that little thing down here below tells you that it's going to be a solid line. So in this case, we actually have a dashed line. So let's make this dashed. Clean that up there without erasing my shading. But that would be how you would complete that first one. So moving on down to number 3. This one is weird because there's no y. Now these are actually easier. The only reason that they're harder is because they're unusual and they're not something that we're used to seeing. So you just have to think of, we have our y-axis and our x-axis. And if you think of x as equal to -5, where is x equal to -5? That's going to be down 5 tick marks over here. And if it was just a single line, it would just be a single, if it was just the x-axis, it would be a single point right there. However, it doesn't specify the y, so y could be anything. It could be -5 up 0, but it could also be -5 up 2, or -5 up 7, or -5 down 3. The point is anywhere along this line, we could have our points. So that is the line x equals -5. That's what that looks like, is that green one right there. Now, two things we have to decide, solid or dashed, and then left or right. In this case, we have the little line below our symbols, so that means it is going to be a solid line, so we'll leave it like that, solid. The other part is x bigger than -5 or is x smaller than? I always like to go back to the old analogy that my elementary school teachers use, which is, think of the gator mouth, and let's improve those gator teeth. We'll call that good. So the gator is going to eat the x, so x is bigger. A gator wants to eat whatever is bigger. So x is bigger than -5. So -5 is the smaller thing. So x is bigger than, greater than, to the right of that -5. So you would shade to the right because x is going to be bigger than the number -5. And then on to our last example down here. This one is in that form that we had seen earlier. Now, in the case of inequalities, I'm going to recommend that you get it into the y equals mx plus b form that you're more used to and not use the test points, because There's some additional steps in figuring out which side to shade on that isn't quite as obvious if you go with the quicker method. So I'm going to recommend get it into y equals mx plus b form. So subtract 9x from both sides. And you have 5y is less than or equal to negative 9x minus 25. Finally, divide everything by 5, and then you will have y alone. Y is less than negative 9/5 x, so we have our slope next to x, and then 25 over 5 is 5, and that's going to be negative. Now, you'll notice that I didn't have to flip my sign. My sign stayed in the same orientation every single time. Sometimes that happens. Whenever you divide by positive numbers, or if you add or subtract, the sign will not change. It is only when you divide by a negative or multiply by a negative number that that sign will flip. So in this case, we had a positive 5 down here. No big deal. Don't have to flip the sign. So we take our graph, and we see that our y-intercept is a negative 5, so that we have to go down 5, plot our point, and our slope is negative 9/5. So to me, negative 9/5, that's almost the number negative 2, so I feel like I have a pretty steep slope, something like that, if I was just to take a guess. But if we're going to count this out, I have to go down 9 and over 5. So 1, 2, 3, 4, 5, and then to go 9 up from this original dot, we go 5 and then 4 more. So we have a point up here. And if we now look at our slope, it says negative 9 rise, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then over 5, 1, 2, 3, 4, 5. So that's where we get our slope, and then we would just trace our line through that. It says that y is less than that, so I'm going to shade below. And it says that we have a solid line, not a dashed line, because it's greater than or less than or equal to. So it's a solid line, so I'll just leave it as is. So this would be what your graph would look like for number 5.